Okay, here we go with the notes for today. Skills of science, that'd be a good heading for today. So you don't need to start a new page, but maybe just skip a line or two, and then this is your heading for the day. Skills of science. Your first term that I'd like you to write down is experiment, a way to gather information in science to test your hypothesis. Take a moment and write that down. I'd probably underline the word experiment as well. Gathering information in science, test your hypothesis. We experiment with things all of the time. Anytime we get something new, okay? I have a new computer and an iPad that I don't use much. A lot of times I don't know what all the buttons do, so what do? I push them and I see what happens. Sometimes it's good, sometimes it's bad. But that's a way of experimenting. I'm gathering information. Don't write this down. Just say maybe should be repeated. Experiments should be repeated. Experiments must be repeated over and over with the same results. Okay, if I have a remote control for my TV and I push the power button, I'm expecting the power to go on or off. If I push the power button and it comes on one time, and the next time I push the power button and a video plays, okay, it's not doing the same thing, so now I'm confused. If I'm in my car and I push the brake, I expect the car to slow down or stop. If I push the brake and the horn honks, then I'm wondering what's going on. So, must be repeatable. Don't need to write anything here. Experiments should be well planned and have logical steps. The ones in science need to have a plan. We need to have a system. In life, we just sometimes wing it, and that's fine. You don't need to write anything. There are... actually, you better write that. Let's go back. Go ahead and write this. There are experiments called controlled experiments, where they have a control and a variable. So, controlled experiments have two groups, a control and a variable. We worked with this last year a little bit, so maybe you remember. First of all, the control group, and I would write this down. A group that is compared to the variable group. Usually nothing is done to this group. A control group is a group that you do not do anything with. I'll give you a couple examples here in a moment. A group that is compared to the variable group, nothing is done to this group. If I'm going too fast, pause the video and copy that down. The other is the variable group. All factors except one are kept the same as the control group. All factors except one are kept the same. So, we hear about these a lot. If you see those commercials for some sort of drug, like a drug that's going to heal an illness or treat some disease or something, they have control groups and variable groups. If I had a magic pill that I claimed gave you increased brain capacity, okay? And someone else, Mr. DeWitt, also had a pill. It's a different one that he claims made you smarter. The way we could test that is we could get three 8th grade students that get very similar grades, that are similar in intelligence, and we'd give Student 1, my pill. Student 2, Mr. DeWitt's smart pill. And then the third one we would give a fake pill to. So the variable groups would be my pill and DeWitt's pill, and the control group would be the one that we gave a fake pill to that did nothing. Okay, so the control would be that group. Everything else is going to be the same, so we could give them all three of those people a test. The test would be exactly the same. We'd feed them the same. They'd have the same amount of time to take the test, everything there. But the thing that we're changing is the pill. Okay, I gave you one example there. Another good example that I use almost every year is fertilizer. I'm in my shed and I have 3 bags of fertilizer, different types of fertilizer A, B, and C. And I want to figure out which one makes my grass grow the fastest. So what I could do is I could measure off a small piece of grass, 4 pieces of grass, and on grass plot 1, I would put fertilizer A. On the second grass plot, I'd put B. On the third, I'd put C. And then on the fourth one, I would put nothing. And I would make sure that all of the other variables are the same. They get the same amount of water, sunlight, things like that. The only thing I'm changing is the fertilizer. And then after so many days, maybe 1 week, I measure the height of the grass and see which one grew more. And I could determine which fertilizer was best. Maybe they're all the same. But we need that control group, the group that we do nothing to, because let's say we did that and after 1 week, the control group was the best. Well, then actually the fertilizer is not only not doing its job, but it's doing worse than no fertilizer at all. So we need something to compare it to. Another term that I'd like you to write down is theory, an explanation based on a hypothesis that has been proven many times. An explanation based on a hypothesis that has been proven many times. There are 3 things you'll hear us talk about. One is a hypothesis. It's what you think. It's an educated guess. A theory is much stronger than a hypothesis. And then you'll hear a law. A law is stronger than a theory. So you've probably heard of like the Big Bang Theory. Not the television show, but it's the theory of how the universe became, that there was a big explosion and a bunch of rocks went shooting everywhere. That would be the big thing, Bang Theory. The theory of evolution is another one, how animals and plants changed. There's a lot of evidence for it, but it's not 100% accepted. All right, so steps of the scientific method. We are going to list the 8 steps of the scientific method. We're going to be using these in our example problems today, so make sure you write these down. Number 1, state the problem. You have a problem, maybe it's a question, okay? Ask the question, that would be the same thing. So, the other day my lawnmower was not working, okay? It would run, but something was going on with my blades and they wouldn't turn, okay? So my problem would be my blades on my lawnmower do not turn. Gather information on the problem. Write this down, please. So with my lawnmower, I gathered information. I shut it all off and I looked at it. Okay, I am not an expert when it comes to machines, but I know some basic stuff. So I cleaned out some lawn clippings around the belt, looked at it all, jiggled some things. I took a look at it. I also did some YouTubing. Okay, I YouTubed my riding lawnmower won't work. My blades won't turn. and you'd be surprised what information you could find. Third is come up with a hypothesis. This is an educated guess. Write this, by the way. My hypothesis with my mower was that my clutch was out. The wheel would not spin that drives the belt that drives the blades. That was my hypothesis. It could be wrong, it could be right. Who knows? Then I designed an experiment. After gathering all that information and checking everything out, I called a repair store and I ordered a new clutch. That was I'm going to take off the new clutch, old clutch, put on the new one, and see what happens. I performed it. I actually did it. Write this down. So I took the old clutch off, put the new one on. I recorded my data. Okay, well, I guess there's not real data in this instance. Instead, what I did is I turned on the mower and seen if it worked after I put the new part on. And guess what? It did. I analyzed my data. A lot of times there's numbers with experiments. In my case, there is not. But I mowed a little bit. It didn't make any noises. It worked. So I thought that was successful. Then I looked at the end and I stated my conclusion. Okay? Your conclusion is your hypothesis right or wrong, or why? And why? Well, my hypothesis was my clutch went out on my mower. And it appears as of right now, after 2 mowings, that I am correct, that it was the clutch issue. So that's how you're going to go through the scientific method. All right. That is all for the note.